Across 3 continents, winter has stopped behaving like winter. Cities that rarely see snow are buried under it. Regions accustomed to cold are experiencing Arctic conditions that have not been recorded in generations. And in places where winter typically means dry cold, relentless atmospheric rivers are unleashing flooding on a scale that is overwhelming infrastructure built over decades. But what happens when winter does not just intensify, when it fundamentally shifts its behavior across an entire hemisphere at the same time? This is not a collection of random weather events. This is a pattern. And if multiple continents are being hit simultaneously, what does that reveal about the larger forces shaping our atmosphere? To answer that, we need to zoom out. Let us map what is unfolding across the northern hemisphere. In North America, Arctic air masses have been plunging south with unusual frequency and persistence. These are not brief cold snaps. These are prolonged periods where temperatures drop 20, 30, sometimes 40 degrees below normal. Power grids designed for typical winter loads are being pushed to their operational limits. Wind chill warnings extend across regions spanning thousands of kilometers. The strain is not just meteorological, it is infrastructural. Across the Atlantic, Europe is experiencing a different but equally disruptive pattern. Rather than cold and snow, much of the continent is dealing with persistent rainfall and flooding. Atlantic storm systems that would normally track across the ocean and dissipate are instead stalling over land. Rivers are breaching their banks. Urban drainage systems built to handle typical winter precipitation are being overwhelmed. The water just keeps coming. In Asia, heavy snowfall and severe cold waves are disrupting transport networks and straining energy systems. Mountain regions are seeing snowfall totals that exceed seasonal norms. Urban centers are grappling with conditions they are not equipped to handle. The cascading effects ripple through densely populated areas, where even moderate disruption affects millions. These events are happening simultaneously. That is not a coincidence. That is atmospheric physics playing out on a hemispheric scale. What makes this winter different isn't necessarily the raw intensity of individual storms or cold outbreaks. We have seen powerful winter storms before. We have seen Arctic blasts before. What is different is the persistence. Weather systems are stalling. They are parking over regions for days, sometimes weeks, rather than moving through in the typical 48 to 72-hour cycle. An Arctic outbreak that would normally sweep through and exit is instead lingering, allowing cold to penetrate deeper into infrastructure, ecosystems, and daily life. A storm system that would typically deliver rain and move on is instead circulating in place, dumping precipitation until rivers cannot absorb anymore. This persistence amplifies damage. A single night of freezing temperatures is manageable. 5 consecutive nights start causing pipe bursts and equipment failures. A day of heavy rain is absorbable. A week of it causes flooding. The mechanism behind this persistence involves large-scale atmospheric blocking patterns. When high-pressure systems become stationary in certain positions, they act like atmospheric roadblocks, forcing other weather systems to slow down or redirect around them. This creates a traffic jam in the sky, and the consequences play out on the ground. The jet stream, that river of fast-moving air that typically guides weather systems in relatively predictable patterns, has been exhibiting pronounced waviness. Deep troughs and ridges form and then persist rather than progressing eastward as they normally would. This creates pockets where weather gets stuck. Ocean temperatures also play a role. Warmer than average sea surface temperatures in certain regions provide additional moisture to storm systems. More moisture means heavier precipitation. Whether that falls as rain or snow depends on the air temperature, and the fuel source is amplified. To understand why weather systems are behaving this way, we need to understand the jet stream. Imagine a river of air flowing around the northern hemisphere at altitudes of about 9 to 12 kilometers. This river, the jet stream, separates cold polar air from warmer air to the south. It flows from west to east, but it does not move in a straight line. It waves and meanders, creating valleys and peaks. When the jet stream takes on these wave patterns, it steers surface weather systems. A dip southward, called a trough, pulls cold air down from the Arctic. A bulge northward, called a ridge, pushes warmer air up from the south. Under normal conditions, these waves move. The entire pattern progresses eastward, which is why your weather changes every few days. A cold front moves through, then conditions moderate, then perhaps a warm front arrives. There is a rhythm. But when the jet stream's waves become very pronounced and stop moving, when they amplify in place, weather gets stuck. That trough pulling Arctic air southward stays there. That ridge blocking moisture-laden storm systems from moving east persists. The result is weather that becomes less like a changing playlist and more like a song on repeat. The polar vortex adds another layer to this. The polar vortex is a large area of low pressure and extremely cold air that sits over the poles during winter. It is always there. When it is strong and stable, it keeps Arctic air locked up near the poles. When it weakens or becomes distorted, pieces of that Arctic air can break off and travel southward along the pathways carved out by the jet stream. Stalled atmospheric patterns multiply damage because systems have time to exhaust resources. Emergency services work around the clock. Salt supplies for roads run low. Heating systems run continuously. Insurance adjusters cannot keep up with claims. The cumulative effect of persistent conditions exceeds the impact of brief, intense events. The cascading impacts of these persistent winter patterns extend far beyond weather headlines. Power grids face extraordinary strain. Electricity demand spikes as millions of people run heating systems at full capacity for extended periods. At the same time, some renewable generation drops, with solar panels covered in snow and wind turbines iced over. Natural gas demand surges, creating price volatility. In extreme cases, grid operators implement controlled outages to prevent total system failure. Transport networks experience widespread disruption. Airports cancel hundreds of flights as de-icing capacity is overwhelmed. Road networks become impassable, cutting off communities and disrupting freight movement. Rail systems that operate in cold climates struggle when conditions exceed design parameters. Maritime shipping faces delays as ports deal with ice or storm damage. Insurance markets absorb enormous costs. Flood damage claims accumulate. Frozen pipe bursts damage homes and businesses. Vehicle accidents increase. Agricultural losses mount as crops and livestock face conditions beyond normal winter stress. Reinsurance companies recalibrate risk models as patterns emerge that were not anticipated in historical data. Supply chains reveal their fragility. Just-in-time logistics systems have little buffer for multi-day delays. Warehouses run low on inventory. Manufacturing facilities shut down when workers cannot reach them or when power becomes unreliable. The economic ripple effects extend far beyond the regions experiencing the weather itself. This is how meteorological disruption becomes economic disruption, and why understanding these patterns matters beyond mere weather curiosity. Behind every statistic and infrastructure metric are human beings adapting to conditions that exceed normal experience. Evacuation orders displace families from flood-threatened homes, often in the middle of winter when temporary shelter options are already strained. People watch as water levels rise past sandbag barriers they have spent days constructing. The uncertainty of when they can return adds psychological weight to physical displacement. Flood damage destroys not just structures, but the contents of lives. Photographs, documents, heirlooms. Water contamination creates health risks. Mold development begins within days, turning a temporary evacuation into a long-term housing crisis. Cold exposure becomes a genuine survival concern. Vulnerable populations, elderly individuals, people experiencing homelessness, and people in inadequately insulated housing face life-threatening risks when temperatures plunge and remain low. Hypothermia casualties increase. Emergency rooms fill with cold-related injuries. Emergency services operate at capacity and beyond. First responders work extended shifts. Ambulance response times increase as road conditions deteriorate. Hospitals activate emergency protocols. The sustained nature of these events means there is no break, just continuous demand on finite resources and exhausted personnel. Communities demonstrate resilience. Neighbors checking on neighbors, strangers pulling stranded motorists from snowdrifts. But resilience has limits, and persistent extreme conditions test those limits day after day. What we're observing fits into a larger pattern that meteorologists and climate scientists have been tracking with increasing attention. Weather has always been variable. Cold winters and warm winters, wet seasons and dry seasons. This variability is fundamental to Earth's climate system. What's changing is the character of that variability. Weather patterns are increasingly exhibiting persistence and intensity characteristics that fall outside historical norms. Systems stall more frequently. Temperature and precipitation extremes are occurring with patterns that suggest underlying shifts in atmospheric circulation. The mechanisms aren't fully understood. Atmospheric science is complex, involving interactions between oceans, ice cover, atmospheric composition, and solar radiation across multiple timescales. Researchers are actively studying how changes in Arctic temperatures, ocean circulation patterns, and jet stream behavior interconnect. What is observable is clear. The frequency of persistent blocking patterns has increased. The amplitude of jet stream waves has grown in certain seasons. The moisture content of the atmosphere has risen, providing more fuel for precipitation events. These aren't speculative projections. These are measurements. The challenge for science is understanding causation, disentangling natural variability from anthropogenic influences, identifying feedback loops, and building models that can anticipate future patterns. For those experiencing these winters, the immediate reality matters more than long-term attribution. But understanding that these events fit into broader atmospheric changes helps explain why multiple continents are being hit simultaneously, because the systems governing Northern Hemisphere weather operate at planetary scale. Winter has always tested human resilience and infrastructure. What's unfolding across multiple continents demonstrates that when atmospheric patterns shift from their typical rhythms, the impacts cascade through every system we've built. The simultaneity of these events across North America, Europe, and Asia isn't coincidence. It's the signature of hemispheric scale atmospheric disruption. Blocking patterns and jet stream behavior don't respect political boundaries, and they operate according to physics that plays out across thousands of kilometers. Understanding these patterns won't stop the snow from falling or the floods from rising, but it provides context for why modern infrastructure is being stressed, why emergency systems are being overwhelmed, and why the winter season is increasingly becoming a period of heightened risk rather than predictable cold. We've built our societies around certain assumptions about weather variability. What happens when those assumptions no longer hold? If you found this analysis valuable, subscribe for more global explainers that connect the dots across continents. And in the comments, let us know where you are watching from and what this winter has looked like in your part of the world.